This topic is about how to check the quality of open data, and we are taking the case of geospatial open data. So you can have, for example, something like OpenStreetMap in mind, or any kind of data provided by big city, especially in Europe. So one point about open data is to be sure that they are reliable, and right now we've got a lot of imagery from space or from aerial imagery. And so with deep learning, we'll see how we can use this kind of imagery to check if our open data are yes or no enough reliable. So the point is to check if between two kinds of data sets there is enough differences, yes or no. So that will be the main goal. And the first kind of data set is imagery, and the other one will be our open data. So as I said, we will use deep learning stuff. So we'll use a computer vision algorithm to help to recognize from imagery patterns. So it's a supervised kind of deep learning. So we will need to provide to our neural network two kinds of data as input, imagery, of course, and also label to help him to train and to be able to recognize what is supposed to extract. Once we train the model, we are then able, only from the imagery, to predict what we want, what we have been trained the model for, and then to compare with our alternate data set to be sure that is it reliable, yes or no. So that's the main concept. What is the technical solution to do that? Is to provide here a framework, an open source one, called RoboSat.pink, and this framework is dedicated to help you to perform computer vision stuff on imagery, and so to perform three use cases. The first one is the dataset quality analysis. The other one is to spot any kind of change detection between two time steps from your data. And the third one is to train a model on a small area and to predict on a broader one. So it's open source, as I said. So if you want to play with the code, it's on GitHub. There are several contributors, and it's MIT, so it's really permissive license. It's easy to deploy, so if you want to play with, it's a one-liner. And we improve a lot of existing computer vision stuff. So it's not only as simple that using already computer vision algorithm. So we enhanced classical semantic segmentation model to recognize pixels from your input imagery. And we also improve the way that the model learns itself. So if you see in this example, a classical way to recognize from the imagery and the label the pattern is to use a classical cross-entropy loss function. And so by keeping the semantic topology, we can improve the accuracy of the prediction, and so help to improve the pattern and the quality of the pattern in the output. It's a command line interface based, so you don't need to develop yourself, or you don't need to bother to do it, to play with. It's only it could be launched only with command line. And it will help you to save time with the data preparation. So when you play with deep learning or any kind of machine learning stuff, you will take a lot of time with your data preparation. So this framework will help you to save time by providing you several small tools, the pink ones, each tools are able to help you to prepare your input data, and at the end to get a training data set you could play with. So it will help you to save time and to directly able to train a model. It's also a point with data. You will in fact, there is an issue about the labels. So most of the time, you will lacking of enough quality label. And so with data augmentation, we help you, even if you don't have a lot of labels, to train enough the model with a small data set. And so if we put all this kind of improvement and enhancement and tuning inside this framework, we're able to play with a plain open data to train a model and to check the quality. So here, there is a tutorial online. If you go on this URL, you will be able to see a step-by-step, a tutorial to use plain open data with this framework and to check the quality of your geospatial data set. So what we do, we retrieve and download plain imagery from a city. Here it's from Grand Lyon in France. And so we retrieve from their open data server imagery. We retrieve also the official labels related to building footprints. So here in green, it's related to what the official data are about the footprint. And so we launch a training on the model. So in pink, it will be able to predict from this imagery, once it's been trained, where from the imagery the buildings are on place. And so once we've done that, the next step is to clean the training data set to be sure that there will no part of the imagery and the labels where there is still some inconsistency between the both. And so here, if you remind, in pink it's what is predicted by the model. In green it's supposed to be in the official data. And when both are green and pink, it becomes gray. So every time it's gray, so it means that both the prediction and the official label are agree. So here, for instance, there is a place where it's supposed to be a building, but you can see here that it's under construction. So you will want to remove this kind of input data to be sure that your model don't be trained on inaccurate data. And with this tool, we help to really quickly can clean the data set. So with only a few human action, you wanna be able to clean your data set. And once you've done that, you can train again the model with a clean data set and get this kind of result. So here there is an improved consistency between the official data and the prediction, and it could help to monitor something like change detection. So you can see here in this example that the main part of the building was obviously detected, but some part of the building were not present in the official data. And also, if you zoom out, you can have a focus on area. Here it's with the pink squares, where there is a significant inconsistency between your data set and the prediction. So it can help you to directly see that, for example, here, there is obviously some area where there is a lot of inconsistency between both. And so to focus and if you zoom in, you can get this kind of information. In here, there is a lot of buildings who are not present in the official data, but obviously from the imagery, the model is able to detect them. So it can help you to save time to quickly check if your open data is yes or no reliable, and if yes, if it's the case in all your broader area or only on small parts. If you play with other kind of data set, once you've trained once a model, so for example here we switch with OpenStreetMap, and so we can perform the same kind of checking with the point to be sure that your two data set get the same kind of classification. So here, if in the official data, parking, for example, is considered as a buildings, it could be something will be an issue if you check with another kind of data set. So what about the stacks? There is three kind of open source stacks related to these tools. The first one is a GIS one. The other one is related to computer vision, and the third one is related to deep learning. So there is three kind of stacks involved in this solution. The point is to keep the code base as tiny as we can, even if I said that it's a command line interface, you've got a Python API. So you can extend it if you want to change something. So if you want another kind of model, it's possible. If you want another tool, you just have to add a new one, and so on and so on. So it's really easy. It's really designed for to extend it to your own need, as since you've got something quite related. So computer vision and geospatial data, you can play with it. What next? There is two kind of next point. The first one will to be able to get some quite decent result, even if we've got a low resolution imagery in input. Because we've got a lot of low resolution imagery for free crust, so it could change a lot of things if we are able to deal with this kind of data set. And the other one is to be able to predict at low cost on a wide area, because here it's just a small area like a city. If you want to play with something a bit bigger, it will be fine too, but if you want to play with something like Europe or even a world, it doesn't right now really work without huge infrastructure to make it work. So as a takeaway, right now you already got an open source solution dedicated to geospatial imagery, pattern recognition, and quality analysis. And so, yeah, just play with it. You can use a plain open data to train model. And it's brand new because because before we are obliged or to use already existing data set or to make it to create labels by hand. And the third one is we still need to improve the speed of the predict to make it scale at large. Thanks.